Okay, so for section 1.4, we're going to have to use all of these. Yours doesn't have to be green, just some kind of something, because you're going to end up writing in your book a little bit on this one. So let's start with definitions. We have one here where a figure is an angle if and only if the union of two, it is the union of two non-collinear rays, sides with a common endpoint and vertex. And this is an example of what we're talking about. That's one ray and that's the other ray, and Y would be the vertex. And then down at the bottom, we have another definition of two coplanar angles are adjacent if and only if they satisfy these three conditions. Now, one of the interesting things about the conditions is that they cannot have any common interior points. So they say that they have to have the same vertex. And they say that they have to have a common side. Well, this angle and this angle both have common sides and a common vertex, but what makes these adjacent is that they don't share any interior points. If we called this one my common side, then this angle, ACB, could be said that it was adjacent to ACD because they have a vertex and a common side. That's why we have to have three, because they would share interior points up here. So angle ACB is adjacent to angle ACD, BCD. On the other side, we finally get to use blue. This is interesting information that you may or may not know. I'm guessing you probably do. You're pretty good at this. But you can find the degree and measure of an angle with a protractor, and they give information about which scale you should look at and why. So there's that information. Doesn't mean that you're going to ever have to write that down. It's just something that's good for you to know. And then they give definitions of an acute angle, which means that it measures, little m means that it measures between 0 and 90. A right angle is exactly 90, and an obtuse angle is between 90 and 180. Some books use a straight angle. My guess is your book doesn't, because it doesn't mention it here, but some books do, and that's okay. You know we're going to highlight postulate 8, right? But we are not going to highlight postulate 9. Postulate 9 is one of those things that it's good to know, but it's not something that you're ever going to say, oh, by the protractor postulate, blah, 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 blah. That's not anything that's going to happen. But it does lead to a lot of theorems and corollaries beyond that, and that's what we need to worry about. So we're going to have this theorem 1.6. And then on the next page, we're going to have a definition up here at the top. Ooh, my top moved. Definition up here at the top about two congruent angles are congruent if and only if they have equal measures and symbols. It means this. I highlighted that because I wanted you to know that the symbol is that, and that means that the measures of those are equal. And then, of course, they throw your example out here on the side. But then they throw in some more theorems. So you've got this theorem, and you have this angle bisector. And you'll get to play around with some angle bisectors as soon as my mom finishes with her video. So there's the picture for the angle bisector. And they give a definition again of between, but you need to know that the bisector of an angle is if it divides the angle into two congruent angles. And that is it for the highlighting in section 1.4. Come back for 1.5.